Section 7.5 is called Algebraically Defined Vectors and the Dot Product. So we're going to look at some important properties about vectors and especially dot products. When we look at the vectors, this is what a vector looks like. They start from the origin and they have a magnitude. So how big the vector is called, this is called magnitude in math class. And the angle the vector makes with the x-axis is called the direction of the direction angle for the vector. And then if you look at the vector notation, they use these symbols, and its x value is called A, and its y value is called B. So vectors, they have two components, x value and the y value. And this is some of the homework questions under this title, magnitude and direction angle of a vector. So whenever we have a vector u, which we can put this notation to express it, it has an x value and it has a y value. We can find its magnitude. Magnitude means these absolute values around the vector. It represents the magnitude of the vector. Will be calculated taking the square root of a squared plus b squared. This is how we find the magnitude of the vector. As we can guess, this is still coming from the Pythagorean theorem. And the direction angle theta will be calculated using this relationship. Tangent of theta is equal to b over a, where a is not equal to 0. Here's our first example, and you guys have a lot of questions under this objective when you start doing your 7.5 MyMathLab homework. So question says, find the magnitude and direction for this vector u that they showed me on the graph, and it's located at 3, -2. First of all, magnitude will be expressed in between these absolute value bars. This means we're trying to find the magnitude of vector u, and its formula is we will take the first number 3 and square it, and then we will take the second number -2 and square it. So this gives me a 4, this gives me a 9, 9 plus 4 is 13. So the magnitude of this vector is square root of 13. Now we're going to find the direction angle. We have to be very careful that direction angles, this is always where angle starts from. This is the starting point. And then until we reach to our vector, as you can see, the angle it makes is a very big angle, and it ends in quadrant 4. So the way I handle these two questions are, I always find the reference angle, and then I think about the quadrant because x value is positive, y value is negative. I know that it needs to be a quadrant 4 angle. So it's going to be more than 270 to less than 360. But first, I set up my angle for the reference angle. So tangent of theta is b over a. So tangent of theta is equal to b value is here 2, and x value is here 3. So this is the tangent value for the reference angle. So let's just call it the reference angle. We're going to calculate it by asking to the calculator arctan of 2 over 3. So if you go to the decimals calculator here, and if you ask, so when we ask decimals about arctan of 2 over 3, and make sure that the settings are located in degrees, it tells me that the angle I'm expecting is 33.7. So I'm going to mark here, the reference angle is 33.7. But again, this is the reference angle. So to find the actual itself, the angle we need, the theta itself, will be 360 minus 33.7, which will be probably 326.3. If there is a subtraction mistake, we can fix it. But this is how we're going to find the direction angle for this magnitude. So you need to be very careful about which quadrant it falls into. And then we have questions on the homework about finding the horizontal and vertical components of a vector. For any vector, its horizontal component A will be calculated by multiplying its magnitude by cosine of theta, which theta is the direction angle, and its vertical component b will be calculated by multiplying absolute value of u, which is the magnitude of the vector, and sine of theta. So we have a question here that we're gonna practice. We have the vector w, its direction angle is 41.7, and the question is giving us the magnitude. So this 25 represents the absolute value of w. So the horizontal component is 25 times cosine of 41.7, which is 18.7. And then the vertical component b is absolute value of w times sine of theta. So this is 25 times sine of 41.7. Since this is not a famous angle, we have to get its sine value using a calculator. And either way, when we use a calculator for this vector whose magnitude is 25, its horizontal component is 18.7 and its vertical component is 16.6. And we can express the vector w as 18.7, comma 16.6, which is the combination of the horizontal component and vertical component. So in this example on the slide, I have 3 problems. It says that for each vector we see in the shape, we're gonna write the vector in the form of a comma b. So we're gonna put them in the form of, this is the vector sign and as a comma b. For vector u is this blue vector. Its magnitude is given as 5, and the angle vector u makes with the x-axis is 60 degrees. So for u, we know that its horizontal component is 5 times cosine of 60 degrees, and its vertical component is 5 times sine of 60 degrees. And then 5 cosine of 60 is 1/2. So this is 5 times 1/2. And sine of 60 is √3/2. So I will multiply 5 by √3/2. So this will be as simple as 5/2 is the horizontal component for vector u, and 5 √3/2 is the vertical component for vector u. Now, when we look at vector v, its magnitude is 2, and the angle it makes is 180 degrees. So its horizontal component will be calculated as 2 times cosine of 180 degrees, and its vertical component will be calculated as 2 times sine of 180 degrees. So here, cosine of 180 is equal to a -1, so it's 2 times -1. And then its sine of 180 degrees is equal to 0. If you organize this, its horizontal component is -2, and its vertical component is 0. And this is how we can express vector v in this format. And finally, the vector w, its magnitude is 6, and direction angle is given as 280 degrees. So its horizontal component will be calculated as 6 times cosine of 280, and its vertical component will be calculated by 6 times sine of 280. All we have to do is type these 2 things to our calculator, and we will get these 2 numbers for the horizontal component and vertical component. Another important objective for vectors is something called dot product. We can calculate the dot product of 2 vectors. Let's say the first vector, vector u, is expressed as a comma b, its horizontal component and its vertical component. And the second vector is vector v. Its first component is c, and the second component is d. If we want to find the dot product between these 2 vectors, the notation we need to use is u dot v, and then we read this as u dot v, and here is the formula for the dot product. We will multiply a by c, plus we will multiply b by d, and then we will add them up to find the dot product. So what we are trying to find is with dot product, if the theta is the angle between the 2 vectors, and then we can find the cosine of the theta by doing the dot product between u and v, and then we can divide this product by magnitude of vector u and magnitude of vector v. This will be the formula that we're going to use to calculate the angle between two vectors. Let's take a look at our first example. So we have the first vector u, and it should be represented with this symbol, and its horizontal component is 3, and its vertical component is 4. And we have the second vector v, its horizontal component is 2, and its vertical component is 1. If you want to find the angle between them, this is the formula we need. So we need to first calculate the dot product between u and v. So this is u and this is v. We will calculate the dot product. And then we're going to find the magnitude for each vector. So absolute value stands for magnitude. So let's do the dot product. 3 times 2 is what we need, plus, and 4 times 1. Total is 3 times 2 is 6, 4 times 1 is 4, so the numerator is 10. The magnitude of 3 comma 4 is 3 squared plus 4 squared, take the square root, so that's going to give me a 5. Here, 2 squared plus 1 squared is 5, so this is another radical 5. So this is 5, this is radical 5. Now, if we simplify this angle, 10 and 5, they can cancel out, and then we will get a 2 at the top and a radical 5 at the bottom. And this will be the cosine value of the angle we want to calculate. So if we use now a calculator and type, we need the inverse cosine of this ratio, the calculator will tell us that the angle we need between these two vectors is 26.57. We need to know about the dot product that for angles between 0 and 180 degrees, cosine of theta is positive. 0 or negative. So acute and obtuse, they don't really show up a lot with dot product questions, but they might ask you if two vectors are orthogonal, which means if their angle between them is a right angle, and this is only possible if their dot product is equal to 0. So this is what I mean. When you do the dot product between two vectors, u times v, if their dot product is equal to 0, then cosine of theta is 0 and theta is 90 degrees. Therefore, these two vectors are perpendicular to each other, or they simply call them orthogonal vectors. Now we're going to model some examples from the homework that you're going to solve. Some of the questions on the homework is going to show up like this. It says find the magnitude and direction angle for the vector. So for magnitude, let's just call this vector A for now. And magnitude means we need the absolute value of vector A. So when I want to calculate the magnitude of this vector, I need 6 squared plus 7 squared. So 6 squared is 36. 7 squared is 49. And then when I add them up, that is square root of 85. And I'm going to leave the answer like this for now. But if the homework wants you to change this to a decimal, feel free to use the graphing calculator and convert it to a decimal. Now for the direction angle, which means tangent of theta will be equal to b over a. So in this case, it's 7 over 6. Since this ratio is not something I can recognize using my head, I have to use a calculator. So for theta, I need to type on my calculator what is arctan of 7 over 6. So I will go here and I will tell them that I need arctan of 7 over 6. So it tells me that the angle I'm looking for is 49.4. Again, I have to read the directions when I'm typing these answers to homework, whether they want 1 decimal places or 2 decimal places. Now, I didn't have to change this angle to anything because when we look at this, first value is positive, second value is positive. So the vector concludes in quadrant 1, and quadrant 1, the angle is equal to the reference angle itself. But you might have to think, for example, in this question, x value is positive, y value is negative, and this is only possible in quadrant 4, so we have to keep that in our mind. So this is another question that I copied from the homework, and we're going to practice again. Let's call this as vector A again. First question is we want to find the magnitude of vector A. So I need absolute value of A. which means in a big square root parentheses, I need 2 radical 3 to the power of 2, and then negative 2 to the power of 2. When we square this, root 3 squared is 3, 2 squared is 4, 4 times 3 is 12. And then when we square this, we get 4. When I add them up, that's square root of 16, which will be equal to F4. Now for the direction angle, I need to set up tangent of theta is equal to b over a. So I'm going to ignore the signs for now, and I'm just going to copy the numerical value of b and numerical value of a, or x and y value. And then this cancels this. So this is an angle that tangent value is equal to 1 over root 3. And I do recognize this angle because this is the angle where the sine value is 1/2, cosine value is root 3 over 2, so they cancel each other. So that angle is 30 degrees. This is the reference angle. This is not the angle I'm looking for. This is the reference angle. Again, when I go back to the question, x is positive, y is negative. So I have to find what 30 becomes in quadrant 1. So look, 30 degree is 30 degree in quadrant 1, but it will be 150 degree in quadrant 2. So for the reference angle for 150 is still 30 because 180 minus 150 is 30. Then it becomes 210 in the third quadrant because 210 minus 180 is 30 degrees. However, it will become 330 degree in quadrant 4 because 360 minus 330 still gives me the 30 degree. In this case, the answer I'm looking for is 330 degrees because this given vector has a positive x value and negative y value, and that's only possible in quadrant 4. Another homework question that I copied here, it asks us to calculate the horizontal and vertical component of this vector. Its direction angle is 43 degrees and its magnitude is 97. So horizontal component is, we're going to multiply its magnitude by the cosine of the given angle. And all you have to do is type this expression to the calculator and you will get the answer. Just make sure that your calculator is in degrees mode. And for vertical components, you need to multiply your magnitude by the sine of this angle. And then you will find the answer. Now, we have the next question. We want to find the u plus v, and this is vector u, this is vector v, and we want to add these two vectors. When we are adding the two vectors, or when we are subtracting them, it's like combining like terms, but we have to pay attention to the order of the numbers. So this is the horizontal component for each of them. So we're going to add the 4 and negative 1 for the resultant vector. And then I'm going to add the negative 5 and negative 4 for the vertical component of the vector. So when we add the first numbers, the sum is 3. When we add the second numbers, the sum is negative 9. And this will be the expected answer for u plus v. Next question is asking me if they give me vector r as 7 comma negative 4, how can we find the negative 4? All we have to do is each of these numbers will be multiplied by negative 4. So 7 times negative 4 is negative 28. Negative 4 times negative 4 is positive 16. And this is what we need to find for negative 4r. Now, next question is, we have the vectors u and vectors v. For these two vectors given, we have 3 parts of the problem. First question is just 4 times u, which is very simple for part A. All we have to do is, this is our vector u, and it has only horizontal component. I represents the horizontal component, j represents the vertical component. All we have to do is 4 times 3i, which is 12i. That's the expected answer for part A. For part B, first I need to find the 4u, so 4 times 3i is 12i. And then I have to find the 6v. So we're going to multiply the vector v by 6. So 6 times 2i is 12i. And then 6 times 3 is 18j. before we move to the next part, we have to just combine the like terms. 12i and 12i, that makes total of 24i. And then we have the 18j next. This is how we do part B. For part C, we have v minus 6u. So let's copy the v. v is 2i plus 3j. Now we're going to multiply u by 6. So u is just 3i. So 2i plus 3j copies with me. And negative 6 times 3i is negative 18i. When we combine the positive 2i and negative 18i, that's total of negative 16i. And then we're going to add this with 3j. This is how we find the answer to this question in part C. This is another question that I copied from the homework. We have done this on the presentation as well, but we're going to repeat it again. This question gives us the vector u and vector v, and we want to find the dot product for u times v. So this represents the dot product. And the way we do this question is we multiply the 2 by negative 2. So we're going to multiply 2 by negative 2. This will be added by, then we're going to multiply negative 2 by positive 3. And this is going to give us the answer for the dot product. When we multiply these two numbers, that's negative 4. When we multiply these two numbers, that's negative 6. So the sum will be negative 10 for this dot product question. Another homework question I copied here is, it's asking the angle between these two vectors. The first vector is 2 comma 4, and the other vector is negative 9 comma negative 3. The theta between these two vectors will be calculated using this formula. Cosine of theta is equal to dot product between these two vectors divided by the magnitude of the first vector times magnitude for the second vector. So if we calculate the dot product between u and v first, we're going to multiply 2 by negative 9, which makes negative 18. And then we're going to multiply 4 by negative 3, that makes negative 12. And when we add these two numbers, the dot product is equal to a negative 30. Then we have to calculate the magnitude for each vector. So the magnitude for the first one will be calculated 2 squared plus 4 squared and take the square root. So that's square root of 20. The magnitude for the other one will be calculated as negative 9 squared plus negative 3 squared, and that's equal to square root of 90. Now, once we put them all together, we're looking for cosine of theta for now. The dot product is equal to a negative 30. And then one of the magnitude is 20, square root of 20. Other magnitude is square root of 90. We can simplify this. We can square root this all. But on the calculator, we're going to simply enter, we need r cosine of negative 30 divided by square root of 20 times square root of 90. So let's go to the calculator. And then, first of all, this is not going to be arc tangent anymore. It's going to be arc cosine. And then the numerator is equal to square root of, negative 30. And the denominator is square root of 20. We're going to multiply this magnitude by the square root of other vector's magnitude. And the other vector's magnitude is 90. So this is actually a famous angle. So we could probably simplify these radicals and make the ratio as small as possible. And we would recognize that the angle we need is 135. So this will tell me that the angle we're looking for is 135 degrees for this question. Next question I copied from the homework is pretty similar to what we just finished, but this time the vectors are expressed as 5i minus 7j. So we have to know that this is the same thing as 5 comma negative 7, and the other one is just j. That means its I component is 0 and its j component is just 1. So after putting the vectors into this format, we can use the same formula to calculate the dot product and the magnitude, and we can find the cosine value, then we can do arc cosine. The final question I want to model from 7.5 is, I have the vector v and I have the vector w. For these two vectors, we're going to decide if these two vectors are orthogonal. So which means we're going to check the dot product if it is 0 or not. If the dot product is 0, we're going to call them orthogonal. If not, we're going to say no. So let's calculate the dot product between them. So I need to multiply 9 by -6, which is -54. And then we're going to multiply 6 by 9, which is +54. And we add them up. The dot product is 0. We're going to say V and W are orthogonal because V times W is equal to 0. And this is all I want to cover for 7.5.